on page 11, section 1.2. Still not going, and they give you a little bit of time to not get too crazy hard. Okay? We are talking about angle relationships. Can you ever forget that vertical angles are always congruent? Can somebody know what vertical angles are? What does it mean to be vertical? Across from each other. So any two lines that intersect have vertical angles, correct? Yes. So we know which angles are congruent. 2 and 4, 1 and 3. Okay? That's something we can never forget. Then they start talking about parallel lines. What if you had a parallel line? We'll pretend. Here we go. Parallel line.
Transversal.
Where's the transversal?
One that's not parallel.
One that's not parallel. A, B, and C. Yes, question.
Is the congruent symbol
The equal sign with a little squiggle. So we could say angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. That's an equal sign over there. Okay, those are vertical angles. What happens when I draw a parallel line? Do I create more angles? I created 4 more angles. What do you know about these first 4 angles and the next 4 angles? Are they related, and how? Say that again? Okay, what is supplementary? There are some that are supplementary. What is two? What? All right, let's look again because we are not remembering correctly. All right, let's look in this wonderful yellow box. And it talks about alternate interior angles. Is that 2 and 5, 3 and 6? Is 2 an interior angle? No, it is not. Not related. Somebody said the word supplementary, but we haven't talked about it yet. Yes, there are some angles that are supplementary. Okay? Alternate interior angles. Where are my alternate interior angles? Somebody put a hand up. John. Oh, okay, well.
Wait, all alternate interior are 6 and 4.
Okay, so angle 6 and angle 4 are alternate interior angles. How are they related if the lines are parallel? They're congruent. Okay, I'm going to go ahead and put a congruent symbol. The other ones you said, I believe, were angle 1 and angle 5. Those are your alternate interior angles. And they will be congruent if lines B and C are parallel. Okay, all things that we've done. Next one, alternate exterior angles. Let's start writing smaller. What are our hands up? What's a pair of alternate exterior angles? Haley. Angle 2 and angle 7 or 3 and 7. Okay. How are they related? They are congruent if the lines are parallel. Goes back to geometry. We proved all of this in geometry. Is there another pair of alternate exterior angles? Susie, give it to me. Angle 2 and angle 8. Okay. I don't like the order of the book, so I'm changing. I go corresponding angles. What are corresponding angles? Oh, don't want to do that. Corresponding, sorry. Ew, I don't like writing that word. That's too long. What did you say? Angle 2 and angle 6, and how are they related? Angle 2 is congruent to angle 6. Is there another set of corresponding angles? Angle 3 and angle 5. Are there any others? There were only two on the other ones. Is there only two pair this time? No, there's more. Give me another pair, Alex.
1 and 7.
Angle 1 is congruent to angle 7. And last, Scott, can you give me the last pair? Angle 4 is congruent to angle 8. Okay, does everybody see those? Okay. And they're all congruent. There's one last one, and I always do it last. Same side interior. They name it interior angles on the same side. They're same side interior angles. That's geometry. Okay? We're running out of colors. Same side interior. Yes, ma'am.
Can you also call them co-interior angles?
Say that again.
Co-interior angles.
Yeah. Yeah. They specified just same side. I mean, I guess co means that they're together, but it wouldn't be 1 and 4. Okay. Because they have to be on the same side of the transversal. All right. What are same side interior angles? Give me a pair. 5 and what, Carson? Angle 5 and angle 4. How are they related? They are supplementary. That's the only one, if the lines are parallel, are supplementary. So I'm not putting a congruent sign in there. Is there another one? 6 and 1. Are supplementary. We've proved all of this in geometry. We're going to just take it. We're going to move on. But you will have to know these 4 things to get through trig. Okay? They'll come up again and again. Okay? Especially if they're parallel and how they're related, because we really don't deal with too much that's not. Okay? So if it gives you x's and y's and such, you can find, you set them equal to each other. Okay? Do you have to have a relationship first before you can set them equal to each other? Like 2 and 5. Are angle 2 and angle 5 related at all? No? No, we can't prove that. If the lines are parallel, we can find out what angle 4 is. Right? And angle 4 is congruent to angle 1. So yes, we can get to where they are related. They are not directly related to each other. Does that make sense? So sometimes you have to follow a path. Don't just make assumptions that they're related. Okay? Very good? Alright. Yeah, this section is pretty easy. We're going to get through this whole thing in a day. We might even move our quiz up. We'll see. Okay. Triangles. The sum of the measures of the angles of any triangle is 180 degrees. I know nobody has heard that in ever. It's been forever. All right. Again, this section I almost want to skip. There's something in here that you're supposed to hear or see. Similar triangles. Okay, I really don't want to go through. Everybody knows what an acute, right, obtuse, equilateral, isosceles, and scalene triangles are? Yes. See, some of this is very review. Congruent and similar triangles. What does it mean to be congruent? Exact same size, exact same shape. That's when I can do this and hit that button It says duplicate it, and it's got the exact one, right? It's congruent. All angles and all sides are the same. What happens if I do something crazy like that? They're similar. Were the first two triangles I had up there similar? Yes, because everything that's congruent is also similar. Okay? What do you know about the angles of similar triangles? Similar triangles. Angles have to be, must be congruent. What about their side lengths? They must be proportional. Sides must be proportional. Okay? Alright. Corresponding angles, corresponding sides are just the ones that go together. Right? We're pretty much done. What happens if we know some side lengths? 8 and 5. Go up just a little bit. And 12 and x. Can you find x? Of course you can. What are you going to do? Cross multiply. How are you going to set it up? Is that exactly how you would do it? That's not my first thought. Could we do 5 over 8 equals 12 over x? I don't know. You tell me. Cross multiply, solve for x. See if we get the same thing. Do it twice. So you get the exact same answer. You're multiplying 12 times 8 and 5 times x both sides, both ways. What matters? The order. If you're going small to big, you must go small to big. You can't say 5 is to 12, x is to 8, and just go in a circle. You all know that? Okay. Are we good? Moving on. So if you were to set something up, sometimes I forget if I actually do something in geometry with you. Did we go out and measure the height of the building?
Yes.
Okay. So when we do that, and I try to do it every year, but I know one year I forgot to do it. So I apologize to that one group of kids that I didn't do it with. I don't know. They'll survive, right? All right. So if we go measure the height of the building, okay, wait, we actually measure it. What if we can't measure it? What do we do? Did you do it with Coach King and Algebra 1? Where you did something with shadows, right? So you know your height. Okay. Somebody in here is 6 feet tall, right? It doesn't matter. We're just going to pretend. If you want to say that, I've said many times that I'm 6 feet tall, and it's okay that you laugh. Okay? And you cast a shadow that is 8.5 feet long. Okay, so the sun's kind of farther down, you're casting a long shadow. At the same time, you're standing beside a building. And it's casting a shadow, because you can measure that is 42.7 feet long. How tall is the building? What are we doing? They do flagpoles and buildings and fire trucks. Well, they know it's the fire department, not fire truck. And I was nice and didn't give you feet in inches. You're welcome. What'd you get, Zach? 30.14117647. We will talk eventually about how many decimals we want. You guys have done chemistry, you know sig figs, right? Unfortunately, we do. It will be brought up in this class again. Okay? Significant digits. And sometimes the rules get a little fuzzy. Okay? Because all of a sudden, if you look at this problem, how many sig figs should you have? One. No. Okay? In math, it's a little different. Okay? I personally don't like the way they explain it, which we're not to it yet, but I don't like the way they explain it because there can be different pieces of different answers, different sig figs for each problem. So it's not like a set standard thing. Okay? When we were talking about this building by itself, it's got 3 sig figs, so I would want 30.1. Okay? If it's just giving you a triangle, you go by, if you're trying to find a side length, you go by what the other side lengths are, not always just what the angles are. Okay? When you were doing your homework from last night or 2 nights ago or whenever it was, so it's like, well, in the book it has this, but it had so many decimals. I'm like, they've already done sig figs. Okay? When they were saying convert 32.145, that's 5 sig figs. So that's what they gave them as an answer in the back. That they were getting different decimals. Okay? And I said, it's okay, just leave it all. I'm always okay with more as long as you don't give me 10. Don't ever give me 10 decimals. Okay? Because you don't know when to stop. Not good. Never. Alright, so in the book, the firefighters at the Moranza fire station need to measure the height of the station flagpole. They find that at the instant that the shadow of the station is 18 meters long, the shadow of the flagpole is 99 feet long. The station is 10 meters high. Find the height of the flagpole. Shanice is going crazy because they put meters and feet in the same problem.
I'm going crazy too.
You are?
Yes.
Because of that?
Meters and feet?
That can be a problem, can't it? What in the world? So there's a fire department, and they told you it was, I forgot. The shadow of the station. The shadow is 18 meters long. And later they tell you that the height of the station is 10 meters high. The flagpole they don't know the height of. Which way is the wind going to be blowing? That way?
No, it's actually the other way.
Okay. Random thoughts. The shadow of the flagpole is 99 feet long. Is this problem ginormous? Like we're going to have to convert feet and meters?
Yes.
Really? That's what you were taught in pre-algebra?
Well, it's the same ratio, so you wouldn't have to convert.
You don't have to convert. Why? Set it up. Write down your ratios.
Oh.
This is one, unlike the one Addison told me where she's going 10 is to X and 18 is to 99. I'm not doing that. I want 10 meters divided by what? Can you reduce? What are you going to reduce? Okay, sure. Anything else you're going to reduce? And what is meters divided by meters?
1.
They cancel. So the unit really doesn't matter there. Okay? So that's going to equal what? Over 99 feet. So when you multiply, you've got 5 times 99 feet. I don't know what that is. It's a little less than 500. Actually, 5 less than 500, right? 495 what?
Feet.
Feet. 5 times 99 feet equals 9 times x, which is simply 9x. When we divide by 9, look at there, it will go in perfectly even. How do I know it goes in perfectly even without doing any math? I heard mumbles and jumbles and no actual answers.
John said the right answer.
9 goes into 99.
Why? Okay. Yes, that is one way. You can do 9 times 11, 5 times, but I totally didn't do that. How do I know this number is divisible by 9?
You add
Add all the digits up, and I know 9 will go into 18. So x equals 55. Wait, that was this. 55 what? Feet. So we still get an answer with the correct units without ever having to convert anything. Okay? Are you good? Is it okay if one has feet and the other one is inches? Yes. As long as the same, like your height and your shadow, as long as those are the same units. Okay? A problem that one of the kids go crazy at. A yardstick casts a shadow that's 2 feet long. A yardstick casts a shadow that's 2 feet long. A building casts a shadow that's 24 feet long. How tall is the building?
36 feet.
And they all get stuck because it's the yardstick and 2 feet. That one you do have to convert. You do have to know that a yard is 3 feet. Then you can work it. 3 feet to 2 feet is what? 24. Right, that's way too easy, but yes, that's exactly. Bless you. All right, are we good? All right, see, we've already covered this whole next section. Nothing is new. I know. I did put in attendance and everything. What in the world is going on? All right, so 1.2 problems. So everybody's turning in stuff from 1.1. I'm on page 16.
Did you record it?
I have. Everything that you guys have said has been on, will be on YouTube later today. Alright. We're going to do some problems. Can't leave it at an odd number.
I like that number.
I can do whatever I want. I'm going to input 52 there. Whoa, did I just make it an odd number? Apparently I can't count. 7, 8, 9. Now that I have 9, I need 10.
No, we should just go back to 8. Yes. I don't like make it 15.
Make it 15. We could do number 15. Ooh, there's a good geometry problem.
Well, too much.
I'm adding 33 and 52 into that.
That makes it 11.
Oh, it makes it out.